So let's take a look at Project0. As you've probably figured out, Project0 is just a flimsy excuse to get everybody on OpenMP, make sure you've got it, make sure you can use it before we get into Project1, which will be a much more serious use of OpenMP. So here we go. Great use for parallel programming is identical operations on large arrays of numbers. So let's take two large arrays of floating point numbers and let's just multiply them pairs at a time and put them in a third array. That will be just a good test to get us going. Requirements, pick an array size. 16,384 if you're into powers of 2, 10,000, 50,000, something like that. Don't go too huge. Don't go to 3 trillion because you probably can't. Don't pick anything too small either. Don't pick 4 because as one of the things you'll see as we start to benchmark these things is the overhead of using threading dominates if you've got a small data set size. It's just not worth it. Okay, you need a certain amount to make it worthwhile doing the parallelism. All right, pairwise multiply these two arrays. Do a for loop that says C of I equals A of I times B of I. Be sure to put the pragma OMP parallel for in the line before you do the for. Okay, and you'll see it in the sample code below. Do it for 1 thread and 4 threads, however you want to do it. You can edit the program, do it once, edit the program, do it a second time. You can do it in a loop. The example I'm going to run does it in the loop. All right, set num threads to num_t, whatever that turned out to be. Time the 2 runs. Okay, you click the stopwatch on with this call, you click the stopwatch off with that call. Convert the timing results into mega multiplies per second. And remember, performance is amount of work done in the numerator divided by time in the denominator. So it's going to be multiplies in the numerator and seconds in the denominator. And then we're going to manipulate that to turn multiplies into mega multiplies. That'll just make our lives easier. All right, speed up. Speed up is the execution time with 1 thread divided by the execution time with 4 threads. In theory, the 4-thread version should be 4 times faster. So this should be like 1 divided by 0.25. In theory, we should get a speed up of around 4. We won't. There's always friction. And this will be Amdahl's law, which we'll get to later. If you're computing it to performance like this, mega multiplies per second, then you just invert the fraction. It's the performance with 4 threads over performance with 1 thread. But in general, speed up is bigger number divided by smaller number. Okay, the number should not be, should not be greater than 4. Oh, I'm sorry, the number should be greater than 1. Yes, if not, you've probably swapped the numerator and denominator. Okay, then once you've got S, compute something called the parallel fraction. And the parallel fraction is this if you've got 1 going to 4. Okay, this is not the universal formula for parallel fraction. It's the only the formula for if you have 1 thread and then you're measuring the speed up when you go to 4 threads. Okay, so don't use this beyond this one example. And in your PDF, tell me what machine you ran it on, what performance did you get, what was your 1 thread to 4 thread speed up, what was your 1 thread to 4 thread speed up if it was less than 4, why should it be less than 4? Should it be exactly 4? Should it be more than 4? What do you think? And then what did you get for your parallel fraction? Hint, it should be less than 1, but not, in this case, not much less than 1. Okay, and here is sample code, and other than you setting your array size, this is complete. Again, Project0 is just all about everybody getting up and running on OpenMP before we do something serious with it. And you can see the grading is not too bad. All right, so let's just actually go look at this. So if I get on here and I go edit my own version of the project code. There it is. And I'm going to set the size to 100,000. Why not? We sometimes do things because we can. So here we are. We've dimensioned the arrays. Here we're testing to see if OpenMP is supported. And yep, it'll tell us if it is, it'll tell us if it's not. Here we're just putting numbers into the arrays. Here we're setting the number of threads to use. And here is our for loop for the number of tries. So this is not the performance loop. This is the performance loop here, the one where we're actually doing the work. This is what was talked about in the project notes about doing it more than once and then taking the max performance. Okay, so that's what this outer loop is. T equals 0, t less than num tries, which this program set to 20. Okay, so in here where the work's being done, we click the stopwatch on, we do the work, we click the stopwatch off, and megamults is, well, how many multiplies did we do, divided by the time it took, and then divide by 1,000,000, and that'll change it from multiplies per second to millions of multiplies per second, which is a number easier to deal with. And then here we're checking to see out of those 20 tries, which one produced the biggest result. And that's the one we're going to trust. That's the one that's the closest to being on an unloaded system. And then here we're going to print it out. Number of threads, peak performance, and so on. Remember, LF stands for long float. That's how you print doubles. %D stands for a decimal integer, not double. So we're printing out the number of threads in %D, and there's a reminder what the speed up is. Okay, so I can type this in, and I can say, actually, let me get back into here and let me do a save on it just to make sure. Okay, so G++ minus O proj00 proj00.cpp. That's what we're compiling. The minus O is where will the executable go, minus the math library. I just always include that in minus F OpenMP. There we go. And run it /proj00. And there we go. I had it set to 4 threads. I had numt set to 4. And yep, OpenMP is supported here. And there was our megamults per second. You know, that's not too shabby when you think about 600 million multiplies being done per second. And if we run it again, oh, that's pretty consistent. Yeah, okay, not always. All right, so there are ways to do this. Let me get in and I'm going to do a save again. You can also build this into a make file. Now, if you like make files, this works great. You know, the make file, you create a file called makefile with a capital M. Here is what we're trying to build. Here is what we need to build it. And if we have that, this is the command to build it with, which is what I had just typed in. And so then if you say make proj00, it'll run that. But the nice thing about make is if I say do it again, make proj00, it'll recognize it doesn't have to. It'll recognize that the output has been produced more recently than the input's been changed. So I kind of like make files for that. That way, if I always use the make file, I never get to the point where I forgot to compile before I run something. So there we go. And of course, it's the same compilation. So if we do this, we've got that. All right, so let's look at a script. So I've got a bash script here set up. Oops. And there it is. And this is exactly out of the scripting notes, except it's only using 1 thread and 4. It's saying set num, or it's echoing that so I can see when I run the script what I'm testing. Here it's setting it. So this is slipping a pound define numt and then either 1 or 4, it's slipping that into the top of your program without you knowing, compiling that in, and then running it. Okay, so if I run this and if I just say bash loop dot bash, there we go. Okay, and so I got these two numbers. So I guess as long as we're here, as long as we all have calculators on our phone, 629.37 divided by 275.85 equals a speed up of 2.28. I would have expected more than that. But who knows? Who knows what the load is like? But anyway, the numbers are what the numbers are. Check the uptime. If the uptime is real big, do it on a different machine or come back a little later or something like that. But anyway, this is the advantage of scripting is I just got both tests run, and we're not going to run one test when we start doing the real problems. We're probably going to run 5 versions of the number of threads and maybe 8 versions of the data set size. So you're going to have 40 combinations of parameters in your program. This is where the scripting becomes really helpful because editing 40 combinations is not fun. And yes, you can just put it in the script, it gets run automatically. Then if you need to change the program, you just run the script again. So anyway, this is how to do Project0. So get on quickly, don't waste time. I really want everybody up and running on Project0 right away, because then I know for sure we can move on to the more interesting stuff. So yes, try Project0. I think I think you'll enjoy it as long as you start to establish a good workflow for yourself.